in electromagnetic waves. Now to see some topic, some questions. What are Maxwell equation? Question mark. Write these equations. Set of equations formed by Maxwell relating sources of electric and magnetic fields, charge and current density, are called Maxwell's equations. These equations are as follow. First, Gauss law for electricity, closed integral vector E dot vector dA is equal to q upon epsilon 0. Second, Gauss law for magnetism, closed integration vector B dot vector dA is equal to 0. And third, Faraday's law, closed integral vector E dot vector dl is equal to minus d phi b by dt. And fourth, Ampere Maxwell's law, closed integral vector b dot vector dl is equal to mu 0 ic plus mu 0 epsilon 0 d phi e by dt. By using these equation and using Lorentz force, all basic laws of electromagnetism waves can be mathematically represented. What contradiction is found by using Ampere's circuital law to obtain magnetic field during charging of capacitor? Question mark. In figure A, parallel plate capacitor C is shown in its charging state. During charging of capacitor at time t, current small I bracket t flows, which is obtained from battery. No current flow across capacitor. At a point P outside capacitor, consider loop of radius small r whose plane is perpendicular to wire carrying current. For symmetry, it can be shown that at any point on the loop, magnetic field is along circumferences of the loop and magnitude is equal of at any point of the loop. You can see in figure a parallel plate capacitor C as a part of circuit through which a time dependent current I in bracket T flow. A loop of radius small r to determine magnetic field at a point P on the loop. B, a pod shaped surface passing through the interior between the capacitor plate with a loop as shown in the figure. You can see in figure A as its rim, C a tiffin shaped surface with a circular loop as its rim and flat circular bottom S between the capacitor plates. The arrow shows uniform electric field between the capacitor plates. By using Ampere's circuital law at a point P outside capacitor, closed integral vector B dot vector dl is equal to mu 0 I in bracket T, equation number 1, where summation I is equal to small I in bracket T is total current. If magnitude vector B is equal to B and closed integral vector dl is equal to 2 pi r, then B in bracket 2 pi r is equal to mu 0 small I in bracket T, equation number 2. Now consider another surface shown in the figure B which does not touch current carrying conductor. Bottom of the surface lies in the region between the plates. Also in figure C, consider oval shaped surface which is between the plates of capacitor and radius equal to small r. In figure B and C, current does not flow in closed surface considered. Hence, closed surface having a radius small r by using Ampere's circuital law. In integration vector B dot vector dl is equal to mu 0 summation I integration I dl is equal to 2 pi r summation I is equal to mu 0 small I in bracket t is equal to 0. Thus we get different value of magnetic field outside and inside, which is contradictory. Thus outside plate of the capacitor we get non-zero magnetic field, and inside between plate of the capacitor magnetic field is zero. This contradiction is by using Ampere circuital law. Hence it can be said that there is something missing in Ampere circuital law. Derive equation of missing term in Ampere circuital law. Write its definition and unit. We get different magnetic field inside and outside plate of capacitor by using Ampere's circuital law. Hence some correction is required in this law. If area of plates of capacitor is capital A and charge is capital Q, then electric field between plate of capacitor is equal to sigma upon epsilon 0 is equal to Q upon A into epsilon 0, where sigma is equal to surface charge density is equal to Q upon A. This field will be normal to closed loop considered, and its magnitude will be equal on area capital A of plate of capacitor, and outside it will be 0. Flux linked with closed loop inside capacitor can be obtained by Gauss law. Pi E is equal to vector capital E dot vector capital A is equal to capital E into capital A cos theta, but theta is equal to 0, therefore phi E is equal to E A cos 0 is equal to E A. Pi E is equal to Q upon A epsilon 0 into A is equal to Q upon epsilon 0, equation 1. If charge on capacitor changes with time, then corresponding current I is equal to dq by dt. Differentiating equation 1 with respect to time, d phi E upon dt is equal to 1 upon epsilon 0 dq by dt is equal to small I upon epsilon 0. Therefore epsilon 0 in bracket d phi E upon dt bracket over is equal to I is the missing term in Ampere circuital law. Its unit is coulomb per second or ampere. Derive Ampere Maxwell's equation of missing term in Ampere circuital law. Write its definition and unit and give Ampere's Maxwell law. Thus, by using Ampere's circuital law, magnetic field inside and outside capacitor should be equal. For this, total current I in bracket small t should be replaced by IC plus ID. Then magnetic field in both part will be equal. Therefore I in bracket t is equal to IC plus ID is equal to IC plus epsilon 0 d phi E by dt. IC is obtained due to flow of charge, hence it is called conduction current, and ID is obtained due to changing electric field, hence it is called displacement current or Maxwell displacement current. In any region, product of permittivity epsilon 0 and rate of change of electric flux gives displacement current ID. SI unit of displacement current is ampere or coulomb per second. Thus, by writing I in bracket T is equal to IC plus ID in Ampere circuital law. Close integral vector B dot vector dl is equal to mu 0 IC plus mu 0 ID is equal to mu 0 common bracket IC plus ID bracket over, where I in bracket T is equal to IC plus ID. This means that in a region outside only conduction current IC is obtained. IC is equal to I in bracket t and displacement current id will be 0, and inside capacitance IC is equal to 0 and current will be displacement current id is equal to I in bracket t. Thus missing term in Ampere circuit law, id is equal to epsilon 0 in bracket d phi e by dt bracket over. In general, the law can be written as closed integral b dot vector dl is equal to mu 0 IC plus mu 0 epsilon 0 d phi e by dt. By using this law, magnetic field can be obtained inside as well as outside capacitor.